substitution, like you can tell that some of the integrals you've tried to differentiate, either you can see the answer or you know you can't do it, right? So this method is the only other method that we can, well, there's a couple other methods, but this is the only method that we kind of get into in this course, and it's substitution. So it's actually uses what's the kind of the chain rule in differentiation. There is no chain rule in integration. However, the chain rule in differentiation leads to a very useful method for simplifying integrals. So they're saying if the derivative is equal to f of x and the integral of f of x is this, which is a standard notation or whatever, they're saying if you have a function within a function, this is, remember from grade 12, this is like function composition, right? F of g of x. So they're saying what you can do, if you find the derivative of a function within a function, what you do with the chain rule is you find the derivative of the outside, right? With the inside left alone. Do you remember this? Times the derivative of the inside. So, and then if you simplify this, this is what it looks like. So now to go the other way, they're saying that the integral of this is essentially the backwards. So now how does that work? What they're saying here is if you can figure out what the inside actually is, all the questions that we will be getting will have the derivative kind of in disguise right next to it. So I always laugh when you see this. The integral of fu du is equal to capital Fu plus c. Anyways. So normally if we have something like this in example 1, what do we do? What do we do if we saw something like this? Hint, yeah, we'd expand it, we'd multiply it out. So let's do it that way. So this is just a FOIL, so this would be x squared plus 4x plus 4 dx, yes? Does everybody know what I just did? Okay, so I'll give you a second, find the antiderivative. Do you have an answer?
Give us a second.
Oh no, I see some people in the back that aren't writing anything, so I assume they're done. No, I was actually talking about the guy next to you. Cruz, what's the answer? Oh, don't forget the C. There you go. Now we're going to do the same question again, but we're going to use what's called U substitution. So in U substitution, it's kind of like the chain rule where there's an inside and an outside. Does everybody see the inside would be this x plus 2? So the first thing we do is we designate what we're going to call the inside. So, and we call it U for U substitution. So we let U equal x plus 2. And what we have to do is, remember how the chain rule works? You have to have, you leave the inside left alone and then you multiply it by the derivative of the inside afterwards. So what's the derivative of this? It would be 1. No, derivative. Okay, so now what we're going to do is we're going to now replace everything with just u's. So the integral of x plus 2 squared dx. Now the problem here is I can rewrite x plus 2 with a u. So we'll do that. And this becomes u squared. Does everybody see that? The problem here is I have to replace an dx with something. So it comes from here. Do you see what it would be? If I cross multiply this over, I get that du equals dx. Yes? So that means I can replace dx with du. This only worked this time that they happen to be the same. In other questions, it won't work that way. So now, instead of the dx, I'm going to write du. So what's the integral of u squared with respect to u? Sorry, I don't need an integral anymore. 1/3 u to the power 3 plus c. But of course, the question didn't actually say that. The question said the integral with x's. So you have to replace the u with the x plus 2. So this is 1/3 x plus 2 to the power 3 plus c. So you might say, well, that's not the same as that over there. If I were to actually expand this, so we'll do that just for fun because we remember the binomial theorem really well, right? Do we? Check by expanding. I don't know if you have enough room now, but you can just watch if not. Does anybody remember how it works when we have to the power 3? Remember the Pascal's triangle?
It's like 1, 6.
1, 1, 2, 1, 1, 3, 3, 1. So this was to the power 3. So how many terms do I have? 4. So those are going to be my coefficients, right? So 1, 3, 3, 1, right? And then the x goes down a number, right? So this will be x cubed, x squared, x, and then no x, right? And then this term goes up. So it's 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3. Do you remember this? Plus the c. Okay, so now I'm going to multiply this all in and simplify. So do you see I get 1/3 x cubed? Everybody's good with that? That first term? If I go 1/3 times 3, they will cancel, and I'm just left with the 2x squared. Does that seem right? Does everybody go okay with what I did? If I go 1/3 times 3, it will cancel again, and then I have 4x. Yes? And if I go 1/3 times this, I get actually 8/3 plus c. So you might say, oh, that's not exactly the same. It actually is, because this kind of like merges together as one big C. Yeah, yeah. So do you see they're actually the same answer? You would never actually multiply it out. A lot of the times, the multiple choice, they would just have this answer. And if you did it this way, you wouldn't, unless you expanded it there, you wouldn't know if that was the right answer or not. This? For a simple one like this, yeah. If it's to the power 7, there's no way you're going to multiply that out. Yeah, yeah. And this was just a simplistic example so that we could compare the two answers. Yeah.
Yeah, so like that seems like so much.
So here is all the antiderivatives with the u inside it. So the u represents anything basically that you could have, right? So I don't think you need to rewrite like how you had it with x's and put with u's, because it's the same darn thing. But essentially what you need to know is the antiderivatives. It doesn't matter what these are, right? So here's the steps, the algorithm for u substitution. Make a choice for the u, compute du, make the substitution. At this point, if there are any x's remaining, you need to go back to step 1. That means you chose the u wrong. Evaluate the new integral, replace u by the f of x, so the final answer is in terms of x. Okay, so let's look at this. Here's an example. Integral of 2x times the square root of 1 plus x squared dx. So one of the clues we look for is if we can find a function and its derivative within the integral. So does everybody see the derivative of 1 plus x squared is 2x? And do you see that's part of the integral as well? You'll see on these questions when you start practicing that the derivative is always within. So you know you picked the u right because you can kind of manipulate stuff. So Does everybody see? Then that means my u is going to be 1 plus x squared. Okay, so now, why didn't I pick the square root of 1 plus x squared as my u? Because do you know how to find the integral of that? No. But you could find the integral of u to the power 1/2 though. You know what I'm saying? So that's how I kind of, plus at the same time, we have these x's here. If I would have taken the square root of that and found the derivative, I probably would have had a big mess going on there, right? Like if you picture what the derivative is, the square root of 1 plus x squared. So the hardest part is learning what to look for what you choose your u to be. Okay, so now we're going to find the derivative on both sides. So what's the derivative of u? So we basically are ddxing both sides. So d, I'm going to write it like this. And I'm going to write on this side d dx of 1 plus x squared. Does everybody see what I did? I ddx both sides. Yes? You don't have to do this step, but I want you to see where the magical du comes from and where this dx comes from. Because if you go straight like y prime equals and all this stuff, you won't actually understand if you're not using this notation, right? So what is the derivative of this? You get 2x. Now we do a quick cross multiply. We get du equals 2x dx. Yes? So now we're going to replace this integral. I'm going to write it out. 2x square root of 1 plus x squared dx. Does everybody see the 2x dx is going to replace the whole thing with du. I'm replacing 2x dx with du. You're good with that? Then I'm going to replace this part right here with u. So this now becomes the integral of u to the power of 1/2 du. Does that make sense what I just did? Okay, so now we just integrate like normal. So u to the power of 1/2, what's the antiderivative? Add 1. So, yeah. So you get 2 over 3 u to the power 3 over 2 plus c. And then we put the 1 plus x squared back in. So you get 2 over 3, 1 plus x to the power 3 over 2 plus c. Oh, sorry, yep. It is. And then we're done. What do you think? Easy? Okay, let's try the next one. What do you think? Does everybody understand you can't find the antiderivative the way it's written, right? So what are you going to be?
4x minus 1.
Yes. So u is 4x minus 1. Okay, so now we can start skipping some steps now that you understand how to, or should we do it one more time where we don't skip steps? Okay, one more time. Okay. Does everybody see I'm going to go d dx both sides? D dx on this side gives me du over dx. D dx on this side is, I'm going to skip one step for you. I'm not going to write d dx of this. I'm just going to find the derivative of this, right? So what is that? 4. So the other one I was trying to tell you that you could skip is not writing the dx there and just putting it automatically over there because you know it's eventually going to go there anyways. So there's the steps I was going to skip. Does everybody see? So I'll repeat. This is where I want you to get to because this will take too long and time is of the essence, right? So you find the derivative of both sides. You know this becomes a du over dx, but then you're going to cross multiply this over. So at the same time, write this as du, find the derivative, and attach the dx there. Make sense? Yep. Okay. So this is going to be the integral of u to the power a half. Now,
1/4.
okay, hold on. Okay, so does everybody see this becomes our, what? Now, does everybody see there's not a 4dx? There's just a dx that's left. So I need to move this 4 over here. And again, you don't have to show this step, but you can just do it in your head and put it there. So does everybody see this is now going to be 1/4 du? You manipulate it to make it work, right? So if they only have a dx here, sometimes it actually, they have an extra 4 laying around, and it's, or maybe it's a 2 and then you just have to, you know, multiply it by 2 to get it to work. You'll see once we start doing some of these. Okay, so the 1/4 just kind of lies around for a while we do this, right? So the antiderivative of u to the power a half is, same as the last question, add 1. Yeah, so it's going to be 1/4 times 2 over 3 u to the power 3 over 2 plus c. So the 2 and the 4 you can cross cancel, right? Okay, so then this is going to be 1/6, and remember our u was 4x minus 1 to the power 3 over 2 plus c. So it's not too bad. Like I said, I split this into 3 days or 3 lessons because I want to take little steps as we go. So, all right, next one. Remember, there's no product rule for integrals. That's what a lot of people got wrong on the multiple choice, right?
I'm thinking u is sin x, but then you still have to
So that's the thing. If you choose wrong and you have things lying around still, then you chose, sorry, if you choose something, you have things lying around at the end, then you chose the wrong thing and start again, right? So I don't know if you heard what Josh was saying. He was thinking it was sin x. Is that what you said?
Yeah, because then
I
it's
agree.
squared.
I would say so.
Yeah, but you, no. But you said you don't think that's right. Why?
Because then we would have cos x still laying around, so that the u function would be u squared times cos x.
But here's the thing. Remember when we go through this process, we end up getting some extra stuff along the way. Sin x is cos x.
Right.
So you are in fact correct by choosing sin x.
Yeah.
Now, some people might think, well, why wouldn't you choose sin squared x? Does everybody understand this is actually sin x, the whole thing squared? You should never, like a lot of the times, then you have all these crazy derivatives going on and you only want a simple derivative, right? Once you do this enough times, you can see where you need to go. So u equals sin x. Everybody good with that? So now I'm going to skip a step. Derivative, you get du. Derivative, you get, what's the derivative of sin x? Cos x dx. Does everybody see I cross multiplied and found the derivative at once? So do you see that's this part, right? And that is this part. So everything's covered. We don't have anything extra lying around. So this is the integral of u squared du. Do you see how that worked? Because the cos x dx is getting replaced with du. And the sin x is getting replaced with u, and this is the same thing as the integral of bracket sin x to the power 2 cos x dx. Do you see what I'm saying? Yeah, don't forget the c. Remember that song? Don't forget the constant. Okay, so add 1, you get 1/3, and then you can go directly in if you want. Sine, actually I can just write it as one-third sine cubed x plus c. Everybody see what I did? All right. Next one. What do you think your u is this time? It's just a 5? It's 5x? It is 5x. Like I said, it's kind of like you have to practice it enough to understand what you're looking for. Again, if you choose wrong, it doesn't get you anywhere. You'll have to start again. So u is 5x, which means I'll get the integral of cos u, right, which you can deal with, right? Differentiate, we get du equals 5dx. Okay, so this is my u. I need to have a dx, not a 5dx. So what does this become? 1/5 du equals dx. Or you don't have to show this step if you want to skip, right? I'm just showing my steps right now. So this will now become the integral of cos u. And now when I replace the dx, I have to replace it with a 1/5 du. Does that make sense? So what's the integral of cos u? I'm sorry? Yeah, minus sine u plus c. So then what's this going to become? Negative 1/5 sine of 5x plus c. And does everybody understand, like at any point in time, you can actually just find the derivative of this, right? And see if you get, like, think about this for a second. If I found the derivative of this, what's the derivative of sine x? Hold on, yeah. So, sorry, what? It should be normal sine x. I got tricked by that when somebody said that. Yeah. Yeah. So, but do you see why it's good to check then? Because as soon as I find the derivative of sine x, I knew it was positive cos x. So how did I get the negative in there, right? So I would always check my answer. So the derivative of sine 5x, right, is cos 5x times 5. And the 5 and the 1/5 will cancel. And that's how I get cos 5x. You see what I'm saying? Okay. Is this my last one? No, we got another page. Okay. All right. All right. It's all good. So what is my u going to be? Josh is good at this. Very good. Did everybody see it's x cubed? Now, what made you pick x cubed?
It's always the inner.
Yeah. Yeah. It's kind of like the chain rule where you're looking for the inside. Yeah. Yeah. The brackets kind of give it away too. So u equals x cubed. Du equals 3x squared dx. Everybody good with how that magically appeared? Okay, now, does everybody see I have an x squared dx, but not a 3x squared dx. So what do I have to do? Divide by 3. So 1/3 du equals x squared dx. Again, you don't have to show this. You can just put it directly into your integral like that. So this would be 1/3 the integral. So the x squared dx is going to get replaced with the du. Yes? And the sine x cubed is going to be sine of u. Now this time, when we have the integral of sine, it is negative cos, because the derivative of cos is negative sine, so the derivative of negative cos would be positive sine. Does that make sense? So this would be negative 1/3 cos u plus c. Is everybody good with that? Again, if you're not sure about the sign, find the derivative of that and then see if you're right? So then this would be negative 1/3 cos of x cubed plus c. Again, check your answer. What's the derivative of 1/3 x cubed sorry, negative 1/3 cos of x cubed. Well, the derivative, this would be a chain rule, right? So the derivative of cos is minus sine, so that would make the minus a plus up there, of sine of the same thing x cubed, and then the derivative of this is 3x squared, and the 3x squared and the 1/3 will cancel those 3's, and I'll have that extra x squared. Do you see how it works? You can check your answer, right? Okay. So, you want to try the next one on your own? What is my u in this case? U is going to be 1/3 x minus 6.
So what's the brackets?
Yeah, a lot of the times it's always the brackets. You'll see the next one doesn't have any brackets, but you can probably figure out what it's going to be. Okay, so then du is going to be 1/3 dx. We don't have a 1/3 in there, so what does du become? 3 du equals dx. So, by the way, if you skip these steps and you go directly to U substitution, you'll get these extra 1/3. So you won't get these extra 3's and 1/3 is what happens. And I know the multiple choice, they always have that one where if you skip that step, they have the wrong answer there for you. You know what I'm saying? So it is a crucial step here. So this is going to be 3 the integral of u to the power negative 5 du. Yes? All right, so add 1 to the minus 5, that would be a minus 4. And then multiply reciprocal. So this is going to be negative 3 over 4 u to the power negative 4 plus c. They don't usually leave negative exponents, so, well, we'll do it for right now. And then it's probably not one of the choices. 1/3 x minus 6 to the power negative 4 plus c. They probably will put this on the bottom, you know what I'm saying? And have it up to the power positive 4. Yeah, so maybe I'll just do that. Negative 3 over 4 bracket 1/3 x minus 6 to the power 4 plus c. Like that, you know what I'm saying? By the way, this is the only reason I did this is because this would probably be on a multiple choice. This would probably be like this. But you are more than correct to leave it like this on the response questions. You don't need to simplify. And I actually say don't simplify it. Yeah.
Because last year on the provincial exam, when we looked at the answers, one of the answers for, I think it was a number, it was like 1,000 people, divided by y, and you had to put the divide by y. If you put it from like
y to the power negative 1. You lost marks, yeah. But I know on the provincial exam, you didn't lose marks if you left something like, for instance, 5/10. If you left it as 5/10, you would get full marks. You didn't have to reduce a fraction. So it's kind of the same thing here, where they're just saying if it's a numerical answer, kind of like a numerical answer, any form of it is fine. So that's how you can save time, actually, right? Yeah. Okay, so what do you think the u is in this case? Yeah, because otherwise you don't know how to find the antiderivative e, right? So u equals 2x to the power 4. So du equals
16x cubed.
How are you getting 16x cubed?
I
Isn't this 8x cubed dx? Okay, so we have the x cubed here, but we need 4. Do you see that? We need a 4x cubed. So how can we manipulate this so it's a 4x cubed? Yeah. So 1/2 du equals 4x cubed dx. Does everybody see what I did there? You're just doing algebra, right? Whatever you do one side, you do the other, and make it all work. So then this would be the integral 1/2 the integral of e to the power u. And that's a pretty easy integral now, right? The antiderivative of e to the power u is just e to the power u. So this is 1/2 e to the power u plus c. So this is 1/2 e to the power 2x to the power 4 plus c. You see the 4x cubed gets replaced with 1/2 du. So this 4x cubed dx got replaced with the 1/2 du. Okay, this looks like their last one here, hey? Oh! Yeah. Okay, so yes, a few people shouted out u is going to be ln x. So then du would be 1 over x dx.
And there is a 1 over x.
There is! Look at that! It's in disguise, a 1 over x dx. Huh? Why was it? We just kind of went out on a limb and, hey, it works out. Well, because, do you see how I get 1 over x? There's the 1 over x dx.
And you kind of have to ln x.
So can I ask how you guys, did you just go out on a limb and say it's ln x, or how did you?
I thought of the same way, because you know how it was like sine squared cosec, and we just chose sine. So
Because the derivative sign was the extra
I
thing.
did not.
Okay, so it does, that is a good method. When you pick stuff, think about what's going to be lying around afterwards. If you pick ln x and you find the derivative, it's 1 over x. There's my leftover 1 over x dx. Do you see? So this would be the integral of u squared plus u du.
You might want to move one square.
Yeah, and you should probably. Does everybody understand how I got that? Yeah? And of course, ln squared x is the same thing like a cos squared x. It's the whole thing squared, right? So that's why it's u squared. You know what I'm saying? Okay, so then add 1, you get u to the power 3, and then reciprocal. Add 1, then the reciprocal, plus c. Okay, then we get 1/3 ln 3x plus 1/2 ln 2x plus c. Now, I will caution you that sometimes they combine logarithms together in their answer. You know what I'm saying?
Okay, so it's going to...
So do you remember your log theorems that addition of 2 logs is the same thing as log of the 2 multiplied together?
And then the...
And then this would be, yeah.
Well, if the cube didn't square do then.
Yeah, but see,
So it would be like x
This-
to the power 1/3, like ln x to the power 1/3 cubed.
well, then that would cancel each other, right?
No, like ln x to the power 1/3, all of it cubed.
Right. So if I do this and I have this to the, so does everybody understand? This is kind of like this, right? And then, but this 1/3. Like I think I want to leave this alone actually because I think this gets into complicated ground. The 1/3 just gets applied to the x,
So
yeah.
That's what I was saying. So, and
Because this would be the cube root of x in there.
yeah.
So I think I want to leave this one left alone. But I just wanted to caution you when when you have logarithms that sometimes they put it together.
Okay.
Yeah. In this case, they probably wouldn't.